Hello students, welcome to second lecture of three-dimensional geometry. In this video, I will explain length of perpendicular from a point to line, skew lines, distance between skew lines and distance between parallel skew lines. So let us go ahead with these four topics. So the very first topic is length of perpendicular from a point to line. Let us have one line R is equal to A plus lambda M. And you know very well R is any point having its coordinate XYZ. A is the passing point of the line, given passing point of the line, and M is a vector which is parallel to the given line, or you can say direction ratios of the line. Let us suppose P is a point whose position vector is, let us say, vector P. So now we need to calculate distance of this point P, I should say perpendicular distance of this point P from this line. To understand this, let me draw one figure. Look at this figure. Here L is a line whose equation is given to us, and P is a point from which we need to calculate distance to the line. That is, we need to calculate this distance PM, which is perpendicular distance from point P to the given line L. And theta is the angle between AP and line L. So let us use AP vector cross AM vector modulus is equal to AP modulus vector into AM modulus sin theta. You know this thing very well. From here we get sin theta is equal to AP vector cross AM vector modulus of it upon AP vector modulus into AM vector modulus. Now in triangle PAM, if we use the concept of trigonometry, then we find that PM upon AP is equal to sin theta, which implies PM is equal to AP sin theta. Let us put the value of sin theta from here to this equation. So we are getting AP, or you can write this as like this, both are one and the same thing, into sin theta. And sin theta is AP cross AM modulus of it upon AP vector modulus and vector AM modulus. From here vector AP get cancelled and we are left with PM is equal to AP vector cross AM vector modulus of it upon modulus of vector AM. So this is the perpendicular distance of point P from given line. So in short, you can write this in terms of position vector now. As we know that AP, this AP, point A has position vector A and P has position vector P. So AP can be written as P minus A. So let me write this AP as vector P minus vector A cross AM. Let us see what is AM. AM is the direction, or you can say represent direction ratios of line L. That is, we can represent it by vector M. So cross vector M upon AM, means vector m modulus. So this is the distance of point P from the given line. Let me take one example to show that how to use this formula. The problem is find the perpendicular distance from the point 1, minus 1, 2 to the line r is equal to 6i cap plus j cap minus 2k cap plus lambda times 3i cap plus 2j cap minus k cap. So it is very important first of all to understand that what is A, M and P over here in the formula that we have used to find out perpendicular distance of a point from the line. Let me write the formula first. Distance is given by P vector minus A vector cross M vector upon M vector modulus of it. So I hope you know very well what is P vector. P vector is the position vector of passing point. That is, we are having I cap minus j cap plus 2k cap. Vector A is the passing point of line, position vector of passing point of line, which is this one. So this is 6i cap plus j cap minus 2k cap. Next, I hope you know that what is vector M. M is the vector which represent the position vector of the line, direction ratios of the line. So this is 3i cap plus 2j cap minus k cap. So simply we need to put the values of all these over here. First of all, let me calculate vector P minus vector A, which is equal to minus 5i cap minus 2j cap and plus 4k cap. Now we need to calculate cross product of P minus A with M. So let us find out vector P minus vector A cross M vector, which you know very well can be calculated by using determinant. First of all, let us write I cap, j cap, k cap, then the coefficient of ijk from P minus A, that is minus 5, minus 2, 4, and then M, coefficient of ijk from vector M. These are 3, 2 and minus 1. So let us calculate this thing, which we are getting I cap into 2 minus 8 minus j cap into 5 minus 12 plus k cap into minus 10 plus 6. So we are getting minus 6i cap plus 7j cap minus 4k cap. So this is P minus A cross M, but we need its modulus. So let us calculate modulus of it. P minus A cross vector M and modulus of it. So we are getting 36 plus 49 plus 16 and square root of it. So we are getting, we get here square root of 101. Next, we need to calculate modulus vector M, which is equal to, let us check it, it is 9 plus 4 plus 1. 9 plus 4 plus 1 and square root of it, which is equal to root 14. So, therefore, distance is equal to square root of 101 upon root 14, or you can say whole square root of 101 upon root 14. After rationalization with root 14, you can calculate the result of distance. So this is the way to calculate distance of a point from line. But it is the formula by using which we can find out directly distance. But sometimes with the distance, we need to calculate three more things. These are number one, image of point in the line. As for example, let me draw line over here. This is the line L and here is a point P given to us. So we need to calculate image of this point in this line. So clearly this image will be at equal distance. You know very well that image formed in the mirror at the equal distance from both the sides. So if we join these 2 points, then this M will be the midpoint, or we can say PM is equal to MP dash, where P dash is the image of this point P. So we need to calculate image. Number 2, we need to calculate foot of perpendicular. Means we need to calculate coordinate of point M. And number 3, we need to calculate equation of perpendicular. Means we need to calculate equation of line PM. And number 4, we need to calculate distance PM. So distance PM we have also calculated by using the direct formula. But if we need to calculate distance PM with the combination of any one of these three, then we should go with another method. So with one example, let me explain this method. Let us look at this problem. It is find the image, distance and equation of perpendicular drawn from the point 1, 2, 3 to the line R is equal to 6i cap plus 7j cap plus 7k cap plus lambda times 3i cap plus 2j cap minus 2k cap. So here we need to calculate three things. Number 1, image, distance, number 2 and number 3, equation of perpendicular drawn from this point to this line. So for this, for the calculation of these three, we need to move in a different way. There is no particular formula to find out these three, just we need to move logically. So that logic way is, let me go ahead step by step. First of all, write down the equation of line in Cartesian form. And you know very well, the Cartesian form of this line will be x minus 6 upon 3 is equal to y minus 7 upon 2 is equal to z minus 7 upon minus 2 is equal to lambda. These are the passing point 6 minus 7 and 7. So x minus x1, y minus y1, z minus z1 I used here, and here a, b, c, that is the direction ratios of the line which are written over here, and the point P is given over here. So as we need to calculate the distance of this line, given line is L, which is like this, from point P whose coordinates are 1, 2, 3. So let me draw perpendicular also from here, and let me draw image also. So let me say that this P dash is the image of this point 1, 2, 3, and let M is the midpoint. You know that M is the midpoint of P dash, because P dash is the image of P. So to calculate this P dash, first of all we need to calculate this point M, because if we know the coordinates of M, then by using midpoint section formula we can easily find out P dash. So first of all, let us try to find out this M point, means coordinate of point M. Now as we know that this point M is lying on this given line, so if we calculate the value of x, y, z from this given line, then we can consider that these values of x, y, z represent the coordinate of point M, because I told you in the starting of this chapter that x, y, z may be any point on the line, and that here we can consider that these are the coordinates of point M. So we are getting let coordinate of point M R. From here I am calculating X, Y, Z. So these are 3 lambda plus 6, 2 lambda plus 7 and minus 2 lambda plus 7. So these I am considering the coordinates of point M. Now as we know that coordinate of P are given to us and M we have calculated in terms of lambda. So we can calculate direction ratios of line PM by using x2 minus x1, y2 minus y1 and z2 minus z1. So let me write over here direction ratios of PM are. It is 3 lambda plus 6 minus 1. This 1 I am taking from here. This is x2 minus x1. Then second one is y2 minus y1. This I am taking y2 minus y1. Next third one is z2 minus z1, that is minus 2 lambda plus 7 minus 3. So these are the direction ratios of PM. This here I am getting 3 lambda plus 5, 2 lambda plus 5 and minus 2 lambda plus 4. Now the next point is PM is perpendicular to L. So therefore dot product of direction ratios of line L and PM will be 0. Now direction ratios of PM we have calculated and direction ratios of line are given to us as 3, 2 and minus 2. So let us calculate dot product of it. We'll write here as PM perpendicular to L. Therefore 3 lambda plus 5 into first direction ratio of line is 3 plus 2 lambda plus 5 into next one is 2 I think. Let me check it. Yes. And next one is minus 2 lambda plus 4 into minus 2 and this is equal to 0 because this is nothing but simply the dot product x1 x2 plus y1 y2 plus z1 z2. On solving this we are getting 9 lambda plus 15 plus 4 lambda plus 10 plus 4 lambda minus 8 is equal to 0 and further from here we are getting 17 lambda plus 17 is equal to 0 and we are getting lambda is equal to minus 1 from here. Therefore, we can easily find out foot of perpendicular, that is coordinates of M now. So coordinates of M are by putting the value of lambda as minus 1 in the coordinates of M which we are having over here. So if we put minus 1 over here, we are getting 3. So first coordinate is 3, second one is 5 and third one is 9. So these are the foot of perpendicular or you can say the coordinate of point M. Now as M is the midpoint, so by using midpoint section formula we can calculate coordinates of point P. Let us suppose these are alpha, beta and gamma. So alpha plus 1 upon 2 is equal to, therefore using midpoint section formula we get alpha plus 1 upon 2 is equal to 3. This is the first point. So from here we are getting alpha is equal to 5. Next we are having beta plus 2 upon 2 is equal to 5. From here we are getting beta is equal to 8. Next gamma plus 3 upon 2 is equal to 9. From here, we are getting gamma is equal to 15. So, therefore, image we are getting as 5, 8 and 15, which we have considered P dash. Next, we need to calculate distance PM. Perpendicular distance from point P to the line is PM. So it can be easily calculated by using distance formula, because coordinate of P are with us and coordinate of M are also with us now. So using simply distance formula as you have used in your 11th class, you can do that. X2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, and root of it will give you distance of point P from line. Next, we need to find out equation of perpendicular. Now, to find out equation of perpendicular, I hope you can understood very easily that this will be the equation which is passing through two given points. So, the passing point we can take 1, 2, 3 and another passing point is M. Direction ratios we can calculate by using subtraction of x2 minus x1, y2 minus y1, z2 minus z1, then 1, 2, 3 as passing point. So easily you can calculate the equation of PM. So in this way you can calculate all the four things, that is image, foot of perpendicular, distance and equation of perpendicular from the given point to the given line. So if the question is to find out only perpendicular distance, then there is no need to go to this way. You have to use only the formula directly that I have told you in the previous example. But if you need to calculate all the four things or any 2 or 3 out of that, so you have to follow this method. Now let us study skew lines. First of all, let us come to know that what are skew lines. Skew lines are the lines which lie in the different planes. Means the lines which are not coplanar are called skew lines. For example, you can take that one line is on the roof of your room and another line is on the floor of your room. And you know that these lines will never intersect, neither parallel nor intersect. So the lines which are one on the floor and one on the roof are the skew lines. Or you can say one on one of the wall, another on another wall is also called skew lines. So in the simplest way, you can imagine any two lines which lie in the different planes, or you can say which are not coplanar, called skew lines. Now let us discuss how to find out shortest distance between two skew lines. So as we know very well that equation of line given in the vector form as, let me take line 1, this is L1, having its equation, vector equation as R1 is equal to A1 plus lambda M1. And second line L2 is R2 is equal to A2 plus lambda M2. A1, A2 are the passing point of the lines. M1, M2 are the direction ratios of the line, or you can say the lines which are parallel to L1 and L2. Now there is a very simple formula to find out the shortest distance between these two skew lines. So this shortest distance is given by A2 minus A1. I should say vector A2 minus vector A1 dot M1 cross M2 upon M1 cross M2 modulus of whole, or you can say modulus of numerator as well as modulus of denominator. So by using this formula, we can calculate shortest distance between the two lines L1 and L2. Here it is simply the difference of passing point having dot product with the cross product of direction ratios of the line and divided by modulus of cross product of direction ratios of two lines. For this, let me take one example. Let me take this problem. Find the shortest distance between the lines R1 is equal to this one and R2 is equal to this one. You know very well that we need to identify A1, A2, M1, M2 if we need to calculate shortest distance. So here we are having A1, that is the position vector of line 1 which is through which the line is passing. So A1 is equal to I cap plus 2j cap plus 3k cap. Then A2, that is position vector of passing point of line 2 which is 2i cap plus 4j cap plus 5k cap. Next we need to identify M1 and M2. M1 is direction ratios of line 1 which is 2i cap plus 3j cap plus 4k cap, and M2 is equal to direction ratios of line 2 that is 3i cap plus 4j cap plus 5k cap. Now you need to keep formula in your mind, and this is shortest distance is equal to A2 vector minus A1 vector dot M1 vector cross M2 vector modulus of it upon M1 vector cross M2 vector modulus of it. So it is clear that first of all we need to calculate M1 cross M2. So let us find out M1 cross M2 first, which is equal to determinant of I, J, K in first row and 2, 3, 4 in second row and 3, 4, 5 from here in third row. So let us calculate is equal to I cap into 15 minus 16 minus j cap into 10 minus 12 plus k cap into 8 minus 9. We are getting minus I cap plus 2j cap minus k cap. So we get modulus now M1 vector cross M2 vector, modulus of it is square root of 1 plus 4 plus 1 which is simply root 6. Now we need to calculate A2 minus A1 vector which is equal to the subtraction of two passing point, that is subtraction of these two. We are getting I cap 2j cap plus 2j cap, I cap plus 2j cap plus 2k cap. So this is A2 minus A1. Next let us calculate vector A2 minus vector A1 dot M1 cross M2 vector. And this is very simple to find out, that we need to calculate dot product of these two, and this is equal to 1 into minus 1 that is minus 1, 2 into 2 that is plus 4 and 2 into minus 1 is minus 2. So we are getting 1 from here. So we are getting modulus of it is again 1, same we are getting. So therefore shortest distance is equal to 1 upon root 6, which is equal to root 6 upon 6 units. So this is how to calculate shortest distance between the two given skew lines. From the above formula, that is to find out the shortest distance between the two skew lines, we are getting one very important condition, that is coplanarity of lines. That is how the lines will become coplanar. As we know that shortest distance between the two lines is given by vector a2 minus vector a1 dot m1 cross m2 modulus of it upon m1 cross m2 and modulus of it. Now, if the shortest distance between the two lines becomes 0, it means what? The lines will intersect, because as I told you that skew lines are neither parallel nor intersecting, because they are lying in the different planes. But if these lines get intersect, what does it mean? That these lines are coplanar, and the lines will intersect only when their shortest distance becomes 0. So, therefore, the very condition to find out whether the lines are coplanar or not is that if shortest distance is 0, then we can say that lines are coplanar. So, this implies that a2 minus a1 dot m1 cross m2 is equal to 0. There is no need to calculate the modulus of m1 cross m2. We need to just find out the numerator part, and if this is 0, then we can say that lines are coplanar. Now let us discuss the last topic of today's video, and it is shortest distance between two parallel lines. Here you should keep in mind that if the lines are parallel, then their direction ratios are same, or you can say are in proportion. So what will happen? That if one line R1 is equal to A1, I should put arrow over here. So R1 vector is equal to A1 vector plus lambda m. Let this is line L1. Then line L2 will be R2 is equal to A2 vector plus lambda m, because lines are parallel. L1 parallel to L2, therefore direction ratios are in proportion. So these are the equations of two parallel lines. In this case, shortest distance between these two lines will be A2 minus A1, vector A2 minus vector A1 cross vector M modulus of it upon modulus of vector M. Means instead of taking difference of these two, as in case of shortest distance between skew lines, we'll just take directly cross product with the subtraction of passing point and divided by modulus of the same, that is the direction modulus of position vector we get from direction ratios of the line. So this is very simple to learn, and if you are using this formula 2-3 times, then easily you can learn both the formulas. These two are almost same, and you can solve your questions very easily on the basis of these formulas. So here is example. Find the shortest distance between the lines I cap plus 2j cap plus 3k cap plus lambda 2i cap plus 3j cap plus 4k cap and R2 is equal to 2i cap plus 4j cap plus 5k cap plus nu times 4i cap plus 6j cap plus 8k cap. If you observe carefully, then you find that there is a relation of twice between the direction ratios of these two lines. So therefore given lines are parallel. So we'll write it as R1 is given as I cap plus 2j cap plus 3k cap plus lambda 2i cap plus 3j cap plus 4k cap, and R2 is equal to 2i cap plus 4j cap plus 5k cap plus 2, let me take common from here, 2 mu, and we are left 2i cap plus 3j cap plus 4k cap. So implies that, let me name it as L1 and it as L2. So it implies that L1 parallel to L2. So therefore distance, or we can say shortest distance, is equal to A2 minus A1 cross M modulus upon modulus of M. So let us calculate A2 minus A1. A2 minus A1 is equal to I cap plus 2j cap plus 2j cap, and now we need to find out cross product with it. So A2 minus A1 cross M is equal to modulus of I j k cap, then coordinates of A2 minus A1, that is 1, 2, 2, and the coordinates of M, that is 2, 3, 4. So it is 2, 3, 4. Now let us calculate its value, which is equal to I cap into 8 minus 6 minus j cap into 4 minus 4 plus k cap into 3 minus 4. So therefore we are getting 2i cap minus 0j cap and minus k cap as this one. Now we need to calculate modulus of it, that is A2 minus A1 cross M modulus of it, which is 4 plus 1 root of it, that is we are getting root 5. We need to calculate modulus of M as well, which is equal to, we are getting we are having 2, 3, 4 over here. So it is 4 plus 9 plus 16. We are getting root 29 over here. So therefore shortest distance between these two parallel lines is root 5 upon root 29. So this is the way you can find out shortest distance between the two lines. Solve problems from these topics so that you can master the topic. In my next video, I will start with plane. So till then, keep learning and stay tuned.